So the discussion, as Sandra was saying, is basically on how we use MySQL at Booking.com, and it's about that. So this is the sort of thing I want to talk about why MySQL, where we use it, why we use it, how we use it, history, some things about our replication configurations and things, some thoughts about automation, thoughts on versioning, some information upgrades and ideas on moving into the cloud and things like that. Hopefully you'll find that interesting. So I'm Simon Mudd. I've been working at Booking for 17 years now, so since 2007, when the company was really tiny. I think we had 20 MySQL servers, 20 IT staff, so the company was much smaller, and I work as a site reliability engineer. We aren't DBAs anymore. SREs sound better and exciting. And I'm British, but I live in Madrid. I've been doing that for about 30 years. The MySQL team at Booking consists of about 20 engineers, engineers and managers. It's one of the Belgium events that Fred hosted a couple of years back. We got a prize there, and that's a couple of my colleagues there. And their colleagues are based in Amsterdam, Cambridge, mainly in Amsterdam, but Cambridge, Madrid, which is me, and also Manchester. This is our head office. So we used to have a tiny little office in Amsterdam, and as you can see, this one's a little bit nicer. It's grown a lot. It's quite pretty. It's near Central Station if you go to Amsterdam. And the company was founded in 1996, so a long time ago. And obviously there's some details there, and we cover the main thing we're well known for is accommodation, but we also have rental cars, flights, attractions, and things like that. Some numbers which are boring, so I'll go on to the next page. MySQL at Booking. This is what you care about, I guess. So, why do we use MySQL? Well, for us, the main thing was scale out. We've grown from being a small company to a very large company, and database load kept growing exponentially. And the only way to handle that was to scale out lots of reads, more reads and more reads, and obviously more writes and more writes, but our read to write ratio is very high, and replication provided a solution to do that. For performance, for what for us is most important is very fast connectivity to the database, less so now with TLS and things which most people have to use. Point selects and short range selects are very, very fast. So MySQL from a very fast response rate is very, very good. Data durability, we don't want to lose our data. No one likes that, and we don't like it either. And so MySQL's proved to be very good for us. Manageability, it's everybody had it a long time ago as a toy under the desk, and you could spin it up and do things, and it was easy to configure and change. That's always been very useful. Moving forward, group replication, or Oracle, we talk about in a DBE cluster. We don't use the routing part of that. We just use the native MySQL server part, which is group replication. And that provides basically faster failovers. If one of the servers fails for some reason, you can switch to another member in the group much more quickly. And of course, if you lose a member, you don't have to worry about split brain scenarios if you're using the traditional sort of semi-sync configuration and things. And for us, it's important to have the open side. So we run a community version, not the enterprise version. We can use the enterprise version, but choose community because we can see all the source, we can inspect it, we can modify it if we want to. We don't do that very often, but occasionally we do. And also we currently run several custom plugins which are specific to our usage. And we can do that because we can see how to integrate with the server core. I mean, you can do that even if you've used the enterprise version as well, but we have some specific use cases where we use our own plugins. Where do we use it? I guess the same as probably everybody here. The core transaction processing, so hotel information, accommodation information, so every hotel that's on our website, we need lots of information about that. All the rooms that are available, their sizes, their types, usage, are they for one room, two rooms, apartments? We've got lots of things, that's typical. Of course, the most important thing from a business perspective is we make payments, we want to bill. So all the information we use for that is on MySQL. That's everything is there. And then, of course, the front end, you guys looking for a hotel to go to Spain or Madrid or Italy or anywhere in the world, you need to find the place. You want to find that website to come up. The front end has to provide you with a response quickly with all the data you need, and hopefully the presentation of the page is good, and from that you can find what you're looking for, and that's critical for us as well. We also have users, which is people like yourselves, but also we have hotels. They're our customer as well, and they need information which is different to what you guys need, or a user that's looking to book a hotel. So we have interaction with them, also customer support, and then of course, like any company, lots of internal integration with internal systems and everything else. So we use MySQL for all of that. Everything OLTP is using MySQL. We do use some other software. We use Cassandra and a couple of other things, but mainly MySQL is used for all the transactionally important critical information. Compliance is horrible. No one likes compliance, but we're under lots of different compliance regimes: SOX, PCI, GDPR, now DMA, which is a new thing in Europe. And of course, we run MySQL under those guidelines, those regulations, and everything works fine. Scale. So Andrew was asking about, so how big is booking these days? Well, we have workloads of huge variation in sizes and things, but we have hundreds of clusters running MySQL. We run nearly all our MySQL systems across 3 regions in Europe. So we don't just run in one region, we run in 3 different regions. So if a region fails, we can transparently fail over to the remaining regions, and no one should notice that. Our typical production clusters can run we have hundreds of clusters. We've got thousands of MySQL instances running, and some of our clusters are very large. We had one cluster which is a bit smaller now, which was running with 1,000 instances, literally 1,000 instances spread over 3 regions, because the read load on that system is very, very high, and so we need 1,000 servers. It's fine. If you need it, you just do it. And typical data set sizes in each of the clusters per instance is about 4 terabytes, or a little bit less than 4 terabytes. We have larger systems as well, but for us, the sweet spot, which is easy to manage, is about that size. When you get to 5, say 10 terabytes, then managing the database, if you want to change tables and want to make changes, can become more complicated. It's possible, but it's a little bit more difficult. History. So how has MySQL usage and booking changed over time? So this Oracle will hate me for saying this, but we started using Postgres, but that was in 2003. 2003 is a long time ago. Someone said Postgres looked good, so they used Postgres, but it didn't scale. The load went up, and there were problems, and someone found MySQL, and we switched to MySQL. This was before I joined Booking. So we moved to MySQL, and things were better. It was good, and we could keep scaling, and that was good. And the masters that we ran were on Fiber Channel, and if a master failed, we had to go and configure it manually and disconnect it and move the storage to a different server, and it would take 30 minutes or an hour to switch over, and that was horrible. That was really, really horrible, being called at 3 o'clock in the morning to fix things like that. But that's how it was. And then with MySQL 5.1, we moved from ISM to InnoDB. And that was a huge change, because now we do proper transactions. There was none of this, the server crashes and you lose your data. InnoDB would handle that properly. 5.6 for us was also really important. We ran 5.6 development versions in production on some systems because performance was much better than 5.5. That was really important. Performance was some of the systems we were using, and we ran the test versions for, as I say, about 6 months. So replication for us has always been really important, to get the data from the master or the primary to the replicas, so that we can provide up-to-date read load. So we had minimal RVR, so the changes that were replicated from the master to the replicas was only the minimum required data set to do that. And that helps a lot, because our bottleneck at that point in time was the network. We had 1 gig networking, and we would saturate the 1 gig network on the servers. GTIDs also helped, because that's made switching from one master to another master if something fails much easier, but we had to hack MySQL because we had access to the source to do that online. 5.7 made that possible automatically with changes which basically simplified the process, but we were doing that in 5.6. We adopted Orchestrator, which I guess some of you may know, which is for visualization of the MySQL topology, but it also handles automatic failover of MySQL, and that made life fantastic because then automatic failover, so if the master fails, Orchestrator fixes it and finds another one and changes everything, and life continues. This is when we moved to basically running almost everywhere over 3 regions, because if anything failed, you could configure it and it would be distributed and it would be fine. And basically, Orchestrator allowed us to have better availability and things, and also reduce stress. If the system would handle failure, we didn't have to wake up, we didn't have to fix the problem, we could look at it the next day. What else? Internal tooling. So our tooling's changed considerably over the last 15 years or so. Initially, we ran on bare metal, on on-prem services. We've moved to also using OpenStack, and we're currently using that. We're basically migrating any of the bare metal servers onto OpenStack to provide more flexibility in sizing and things like that. And also currently we can provision to EC2, again virtual machines, so there's no real difference, and we can choose where we want our servers provisioned, in which regions, in which place. Our tooling just handles that, it's just automatic. This is a picture because sometimes we talk about, the replication configuration, the cluster, and blah, 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 but a picture is much easier to understand. And this is a picture from Orchestrator, where you see basically here a primary, the master. You see we have a 3-tier architecture, so you have intermediate masters and then you have replicas here. Our read service is always to the service here. These are intermediate masters which are passing data to the 3rd tier. So you can see the blue dots. You can't see, there are numbers usually shown in Orchestrator which show the number of replicas which are providing the read service. And so there are multiple replicas here. I'm not showing the scale, you can't see that, but you can see that the 3-tier is to reduce some of the load on the primary or the master, because if you go directly from the primary to the master to 500 servers, the load on the master is too high. So to distribute that load, you distribute it over the 3 regions, and that's better. And again, the description here, which is just saying is just describing that. One of the things to be aware of our read replicas, we don't just have a contiguous set of read replicas. Different applications have different workloads, so we have different pools of read replicas, and they talk to their own set of read replicas, which are different to ones which may be used by a different application. That's only if there's interference between workloads. Group replication looks basically the same. The only difference here from our perspective is that rather than a master, a 2nd tier of intermediate masters, we now have a group replication cluster. And this is a similar, different cluster, but a similar setup. And the little castle icons that you see indicate it's a group replication node. But the behavior is the same. We scale out, the read scale out is on the right-hand side, and that allows us basically to have the easy scale out. And again, over 3 regions as usual. So questions about automation. Our system, we've developed it over 15 years, so automation for us is key. I mean, these days, perhaps with the cloud, it's easier to do more complicated things than it used to be if you did it manually, but our automation handles provisioning. We want to provision a cluster of 50 servers or 100 servers. We change a configuration and the deployment happens automatically. Users that want to get access to a database for an application, they just request it and it gets handled. We don't get involved. It's completely alien. So we have database owners. The owners of the database, they allow users or applications to access their database. We don't get involved. It's nothing to do with us. It's a request internal to the system. Auto scaling. So if load goes up, our system detects load goes up, we scale up. We spin up more instances and that provides more load. Failures. If we have a failure, as described with Orchestrator, Orchestrator will detect a failure of a primary and it will just get thrown away. We also have to do maintenance, we have to do upgrades. We want to upgrade to the latest version that's available, so we configure we want upgrades and the automation will gradually handle that. There's lots of compliance regulations that we have to follow, and the compliance is also built into our automation, and so on. And again, for most users, we have an application portal that users can request different things. A typical thing is people want to do a table change, a schema change. You want to add a new column, you want to remove a column, you want to add an index. This is automated. The user requests that, and the end result is it happens. It's automatic. It gets confirmed, and in the meantime, there's no downtime for the system. The applications carry on working. This is something I've talked to the guys at Oracle about. You had like 20 pages of your versioning. It can't be that complicated. It shouldn't be that complicated, but it is. But okay, everyone has their own opinion, so I don't know. So I think clearly what was mentioned earlier, you've got 5.7, don't use it. 8.0 is the latest GA version. There's a bit of a question mark, is it LTS or is it not LTS? I think it is, but Oracle don't want to say. But anyway, 8.0 is old. Get off it, you want to go to 8.4. 8.4 is the LTS version, it's the proper LTS version, and it's the good LTS version, yeah? So it's the LTS version, and if you want to new things, it's also supported, is 9.x. So what should we use? Clearly, 5.7, upgrade, get off it. If you need help, talk to these guys, maybe they'll help you if you need help. So 8.0, I think right now that 8.4 is LTS, you need to get off 8.0, get onto 8.4. And if you want something stable, if you start something new, go on to 8.4, don't use 8.0, go on to 8.4. And if you want something new and exciting and everything else, then 9.x is the version to go to. The other thing, of course, is that when you upgrade, you don't want to have problems. So when you upgrade, you always upgrade through, well, we always upgrade through replication. Because if you upgrade through replication, you never have downtime. Your downtime is the final switch over, the write downtime is the final switch over when you switch your 8.0 server to an 8.4 master, or the 8.4 master to a 9x master, or something like that. Again, the versioning, which I think is confusing. Connectivity, it's clear that from what Marcus said, use the 9.x versions for connectors, for the shell. And in theory, they support the older versions of MySQL. Of course, it may be that you're not running an officially supported language to talk to MySQL, so I guess you talk to your own vendors. So what about us for 8.4? We're not using 8.4 at the moment. We had some infrastructure changes which we had to take preference to over the last few months, or the last quarter or so. And but now this quarter we're basically planning on the upgrade to 8.4. From our perspective, the changes of syntax from using master slave to source replica requires a lot of replication management changes in our code, which uses the old terminology. But once that's modified and once that's done and tested, then we will be moving on to 8.4, hopefully by the end of the year, or maybe we'll at least have initiated that process. And again, that's good. The only thing, the downside from my perspective, is that 8.4 doesn't really provide any significant benefit, except that it's the latest stable version of MySQL. And also to test 9.x, where you want to have a 9.x replica replicating from 8.4, you need to run 8.4. So we'll be upgrading to 8.4 and using then that as an opportunity to test the 9.x innovation releases and hopefully get some new features. Upgrades. So how do we upgrade from 8.0 to 8.4? Actually, it's quite simple. Well, no, upgrades is a general perspective. So most people should upgrade. I think if you're honest, I mean, you can sort of forget about it, but if you don't upgrade, then you don't remember how to. And then when someone says, can you upgrade, you don't want to. So it's good to upgrade. Once you upgrade and you've done it once and you've done it twice and you've done it 3 times, then you can automate it and then you don't have to think about it, and it makes life much easier. Also, if you have bugs, you may need to upgrade. So we occasionally find bugs with Oracle or with MySQL. We report them. The bug gets fixed. We want to upgrade. We may get a patched version of MySQL to resolve that bug, and upgrading is good. So I think generally people really need to know, really need to do that. And I've seen people say, yeah, but we're on 5.6 and we're on 5.5 and we're on 8.0.20, and don't leave it, because also you'll find that maybe problems that you have will get, performance will be better with the later versions. And then again, how do we handle that? So our process, I showed you the tree structure that we had for replication. We upgrade the leaf nodes first. We pick a random couple of boxes, we upgrade them. Do they work? Yes, good, okay. So then we start to do all the leaf nodes. Then after that, we push them onto the intermediate masters, and then eventually, when all the servers except for the primary or the master are running the new version, then we switch the master, and then we're running completely. So downtime during upgrades, or an upgrade from 8.0 to 8.4 is going to be 30 seconds. Clearly, it's a continuous change, and if you see a problem, especially with a major version upgrade, what do? You simply have to, you stop, you analyze what's going on. If necessary, you talk to Oracle, this looks strange, or is it correct? Maybe you need to change the configuration, and you carry on. But it's good to do that, and the process works. It's very reliable, and if you do it through replication, then your downtime in any systems is basically zero. Thoughts of the cloud. So this is not a Booking.com thoughts. These are my thoughts. The cloud sounds great, but you still have to configure MySQL configuration. And if you just assume the cloud configuration, whichever cloud it is good, you're wrong. You have to configure it. MySQL's got lots of knobs. You need to know how to tune those knobs. If you don't do that, you will not get the performance you want. You have less configuration options usually in the cloud, because they want to make sure that you can't break things. But if you know what you're doing, maybe you want to do things which are unusual. And often the cloud will not let you, at least for the managed services. There are less HA options, I think, in the cloud generally. We run through HA over 3 regions. Most cloud vendor offerings, as far as I'm aware, don't provide that sort of option automatically. And then, of course, cloud vendors may, the cloud's great, but the cloud vendors never tell you what they're not good at. So you have to look at what they say carefully. I mean, there's nothing wrong with the cloud, of course. The cloud's good for a lot of people. If you don't have the infrastructure to manage things in many ways, then use it. But be aware of that. And yes, so it's an option, and a lot of people are moving there. We're moving partially into the cloud and then trying to figure out the best way to do that. The other thing that's talked about is Kubernetes. Kubernetes is great, and operators were talked about and things. And I think the Kubernetes idea is very good. The operators, I think, these days tend to be just a GR cluster, so you don't have a large number of nodes. We like to have 3-tier replication. We have multiple Kubernetes clusters. So we want to have MySQL running over multiple Kubernetes clusters, so that if a cluster goes down, we don't die. And these sort of scenarios are not currently covered, as far as I'm aware, by many of the operators at the moment. I'm sure moving forward, they will get better as people come up with more sophisticated solutions and things. So we've got a lot of work to do, and I think this is the place we will start to focus on moving forward. And some people are doing things there already, but it's an interesting place to be. I don't know, we manage MySQL, we want availability, we want reliability. Again, the biggest thing when you're using MySQL is talk to your users, find out what they're doing, why they're doing it, and if you can, help them to do it better. Sometimes can you adapt the product to fit what they want to do? Monitoring clearly is critical. Automation to handle failures is also something which is really useful, because you don't want to handle failures manually. If you can automate the problem away, then you can sleep overnight and don't have to be woken up at horrible hours. And of course, expect failure. Everything fails. It's not necessarily just software, but expect failure and try and handle it. And that's sort of the process and the mentality we have of these things, and that's it. So, thank you for listening. I hope that was interesting. Thank you.